All right, so I'm going to set this up using an ice chart. This is a soluble salt, and I can tell that because I have a CH3CH2 minus group and I have a lithium positive. So if you've got the plus minus and none of them's an H, then it's at the salt part. So if you aren't sure sometimes on how to set these up, again, it's asking about pH, look for the thing that has a K value. And so that's what has a K value. And so I'm going to set this up and do CH3COOH with my water. And then it's going to be making CH3COO minus and H3O plus. Now, this is that. The twos are combined together there. They're the same. So 0.5, that's moles per liter of LiCH3COO minus. And if I want to know how many moles of just the CH3COO minus, I can just look and I can say, well, there's only one of those. In 1 mole of this one, there's only 1 mole of those. So my molarity is going to be the same. So that's my molarity of the CH3COO minus. So I'm going to fill this in like this, ICE. Initially, I have 1 mole of this, 1 molarity, and I have 0.5 molarity of this. I'm going to subtract, I'm going to use X. Had a moment there. I think everyone does. So I've got 1 minus X, and I have 0.5 plus X, and then I have X. Then my K chart, and I know the K value is 1.8 times 10 to the minus 5th. So I already know that. This is my products, which is my CH3, COO minus, times the other product, CH3 plus, or H3O plus, over CH3COOH. So this quantity here, I'm going to scooch it down just a little bit. That's my K expression. Now here's the deal, is that I'm actually going to say that X is way, way smaller than 0.5 and that X is way, way smaller than 1.0. So what that means is that this value just becomes 1 and this value just becomes 0.5. I'll check it at the end to make sure it works. So what I have is 0.5 times X over 1.0 and then 1.8 times 10 to the minus 5th. Of course, multiplying both sides by 1 will just give me 1. I mean, it just gives me the 1. But I'm going to go ahead and divide by my 0.5 at the same time. So that'll cancel all those out so that I just have X. So I'm going to bring over my calculator. 1.8 e to the minus 5th times 1 divided by 0.5 is 3.6 times 10 to the minus 5th. And this is where I can really easily with my calculator do a quick check. I'm just going to compare the X to that term right there. I'm just going to say, is this number divided by 0.5 times 100, is that less than 5%? And yeah, look how small that is. So it's totally fine to make that assumption. And then I just needed to use the pH is equal to the negative log of my X, which is my H3O plus. And so I'm going to go negative log. And notice that I'm tapping the number that's higher up, that 3.6 number. That's what X is. And so it tells me that my pH is 4.44. Now don't get overly excited about doing the problem this way. We've got a faster method.